Chapter 1. Alright. Chapter 1, we will now know basic simulation modeling. And in fact, we will now have some examples. From these examples, you can have the extended version for some further or complicated models. Alright, so let us start discussion. Basic simulation modeling for Chapter 1. This chapter will let you know some terminologies. Well, of course, we have the outlines here. Nature of simulation and some of the other description. Of course, we emphasize these. Discrete event simulation. This is a core of simulation for us. So, of course, I will let you know discrete event simulation. And after that, we will let you have the example using single server queuing system. Well, maybe you have a question. Should we use the single server queuing system? In fact, no, you can change the system to the other system. For example, but I don't focus this, just that you know we have the inventory system, or maybe you can have your own system. Alright, so of course we will emphasize discrete event simulation. And after that, we don't know, in fact, if you want to extend, we can have parallel or distributed simulation or high-level architecture. However, in this part, we don't really have some specific one. We just try to know the concept, how you can extend using parallel or distributed simulation or the high-level architecture. Well, of course, if we have the discrete event simulation, we already have the step in some simulations study. So this one, actually, we want to let you know if you want to have a simulation program. These are the good steps. Alright, a good step in the simulation study. Well, finally, we discuss advantage, disadvantage, and pitfalls of simulation. Alright, so before we start, actually you should understand simulation. Well, I think no problem for that. However, this one keyword actually is key term. Alright, key term. Well, simulation. Well, this is the focus of our course, so we gotta have the keyword of key term here. Simulation. You should understand it's a model of a set of problems or events. Well, we may have a model. And if we have the model, you can have some study of vehicle. We can use to teach someone know how it works. Alright, so this is the definition by a dictionary. And actually, our simulation similar to this definition. We want to really have the models. And with the model, we may have our own way so that you know the system can work according to the model. Well, if we want to do so, of course, we will have the model, and later we use the probabilistic model. Well, let's have the general description, nature of simulation. Well, previously we already know we will have a model, but before we have the model, of course, we have a system. right? So here we have a simple definition system. It's the facility or process of interest. Which one you think you want to study? That is the goal for you. Right? So you will have a target. This target we call system. And we have the system, then it doesn't mean we want to use a real system. Alright, not real system. We will use model. To describe the system, we use model. So what that means, model. Actually, you can have assumptions. Assumption in form of mathematical or logic relationships. Therefore, you can have the model. Well, we focus on model. That says if we want to have the simulation, of course, we need to find model for the system. Well, from the system to find the model. And based on the model, you can have a simulation. If you don't want to use model, of course, it should be the experiment. But we don't really know the experiment. We really have the simulation. Therefore, we need to have the proper modeling for the system. Well, even we have the model, we have two ways to have the solution. The first one, analytical solution. Analytical solution, it is the exact information on the questions you study or the model you study. If you can have this one, then we have the analytical solution. Another one is simulation. First, actually, we have the model, and we want to use a computer to evaluate the model we define numerically, and then this way it's called simulation. Well, up to now, I think at least you understand. We will have a model, and based on the model, you will use a computer to evaluate so that you can have the simulation. Well, up to now, I think you understand model, then simulation. Here, before we study the simulation using discrete event simulation, we gotta have the area to frequently use simulations. Of course, we gotta know we can have simulation for computer systems, right? And also communication networks. Well, of course, for you, generally speaking, you can emphasize transportation system. All right, and the others, in the task book, the authors provide you the inventory system models. Except these, we still have financial systems. We have business process. We have military weapon systems. And of course, we have the manufacturing systems. And of course, you can extend so that you can have your area to apply simulation to study the performance of the system. Well, that's it. So up to now, any questions? Well, of course, I don't know these areas or other areas you can apply simulation. If you think okay for you, so of course you can use simulation to study specifically the performance of the system. Well, using simulation, sometimes you may have maybe some questions or challenges here, it is called impediment. All right, I think some support here. This is a support keyword, providing keyword to all of you. And impediment, this one. All right, so this is the definition by the terms here. Okay, maybe I try to let you know this. Impediment. Well, of course, for this one, impediment, we have a definition in English, or maybe we have the explanation in Chinese already. So here, this is the term impediment. Is it okay? All right, so impediment to simulations. Well, we have the model. It says if we want to have a large scale system, then of course you will have complex models. All right, so this is the first one. Complex model for large scale system. Then maybe for you, you will have the burden. This is the first impediment. And the next one, if we have a complex model or complex system, it will take a long time. Therefore, we have a large amount of computer time for that complex system. And last one, actually, it is not a problem. However, for some researchers, they may have a viewpoint. This kind of viewpoint, simulation is just an exercise in computer programming. The thing, you just have an exercise. It is not a rigorous tool. All right. 这个问题是说它就只是一个好像是个练习，它有一点轻视说你用了 simulation。不过要说，既然是这门课用了 simulation， 当然 simulation 是一个重要的东西。All right, so simulation. Some researchers think it's just an exercise. They don't think it's a rigorous tool. Therefore, they don't think you should use it. However, sometimes we don't have the other way, so of course we need to use simulation to help us. Well, actually we have two major impediments here. Complex model for large-scale system, a large amount of computer time for the complex system. But for the final one, it's just a viewpoint. For all of you, I think if you want to use simulation, of course, you don't think it's a serious problem. So you just understand sometimes you have these, but don't care about simulation. It's just an exercise in computer programming. Never mind these.